Hey guys, so make sure that of course that you are using this video to check your answers to the even problems. All right, so again, we did the odd ones in class together. Use this video to go through and help you check the answers to the even ones. So number one, we did that in class together. All right, so it was very similar to number two. So let's go through the solution for number two. It says compare the ratios of corresponding sides and decide whether the figures are similar. So we have to prove whether they're similar or not. If they are, we write that similarity statement. So let's set up our ratios, right? Let's set up that ratio. Um, let's go through and compare. Let's play this matching game. If I compare here the left side from A to B, 4, it's corresponding to, I would say, D to E. So I'm going to say 4 over 8. All right, let's keep it going. Now if I use kind of the right-hand side from A to C, that seems to be corresponding, seems to be matching up from D to F. So I'm going to say 6 over 9. And then, of course, the last one, right? It's kind of obvious here. The last one down below from would be 8 over 12. So let's write 8 over 12. Once we have our ratios, once we have that comparison, right, we're comparing, let's just go through and simplify as much as possible down to its smallest piece. 8 and 4, we can simplify top and bottom by 4. All right, so 4 divided by 4 is 1. 8 divided by 4 is 2, so that's 1/2. What about 6 over 9? I can divide by 3. I can simplify by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So already I can actually tell that these are not similar. But let me just simplify the last one here. 8 and 12, I can simplify. It looks to be like 4 is going to be my best bet. 8 divided by 4 is 2. 12 divided by 4 is 3. So yeah, even though the last ones do equal 2 over 3 equals 2 over 3, right, that 1/2 is what's throwing us off. So one of these sides is scaled slightly differently. So no, these are not similar. These are not similar, and this is how we proved it here. These are not similar. Whoops. These are not similar, and that's how we proved it. So we no need to write a similarity statement. We can just say NA does not apply. They are not similar. All right, number 3, we did that together in class. Number 4, again, is very similar to that one. It says the following polygons are similar, so we know that they are. One's just a bigger version or smaller version of the other, depending on how you look at it. We want to find the missing side here where our question mark is. Again, I'm going to use a variable instead of a question mark. I'm going to use the letter X. Well, let me go through and write my first fraction, my first ratio. I'm going to say this side X, who is it matching? Who does it correspond to? The left side over here, which is 25. So I'm going to say X over 25 as my first fraction, my first ratio. And that, of course, is going to equal, let's play the matching game again. I'm going to say the top here from 12 units is going to be corresponding. It's matching to the one that says 15. So 12 over 15. Let's go through and cross multiply. If I cross multiply in this direction first, what is x times 15 or 15 times x? It's just 15x. And this is equal to, what happens if I cross multiply this way now? What is 25 times 12? I do not know that off the top of my head. Let me get my calculator real quick. 12 times 25, that gives me 300. All right, if we just go ahead and divide both sides by 15, 15 divided by 15 cancels, and I get x is equal to, what is 300 divided by 15? That gives me 20. That is our missing side length. So again, this missing side length over here measures 20 units. All right, number 5 we did together in class. Let's take a look at number 6. It says find the length of segment X. So we want this little distance right here. We want X. So again, we have two triangles. We have a smaller one and of course a bigger one. So I'm going to focus on the smaller one. I'm going to try to tear these apart. And just a quick picture. It doesn't have to be perfect, right? That's the smaller triangle. Let's label everything that we know. The left side looks to be 10. The bottom side down here looks to be 15. And that's all I know about that smaller triangle. Now let's take a look at the much larger one, right? The larger one is taking a look at the whole thing. The whole thing. So let me draw a much bigger one, right? Just a quick sketch. It doesn't have to be perfect. We're just using it to separate our two triangles. So let's take a look at the left side of the bigger one. So from the top to the very bottom corner down here, well, that's a 2 and that's a 10, right? It's not just 2, it's not just 10. It's both of those smaller distances combined together. Well, what's 2 plus 10? That's going to give you 12. I want to do the same thing, but with the bottom side of this bigger triangle. So the bottom from corner to corner, right? This segment measures 15, this segment measures x. So if I add them together, I really can't. So I can say, I was going to put them right next to each other and say 15 plus x or x plus 15. It's the same difference. So I'm going to say x plus 15. If I added those two together, I would know what the bottom side of the much bigger triangle would be. And that's all I know. All right, all I did was I tore those two triangles apart. Let's just go through and play our matching game again. Let's match up corresponding sides. So the left side over here of the smaller one, 10 is corresponding to the left side of the bigger one, which is 12. So I'll go ahead and say 10 over 12 is equal to, I'm going to compare it to the bottom, 15. All right, it's corresponding to the bottom side over here, which is x plus 15. So I'm going to say 15 over x plus 15. Let's go through and cross multiply. Let me cross multiply in this direction first. What is 12 times 15? I don't know that off the top of my head. Where'd it go? 12 times 15. That gives me 180. And that is equal to, be careful when you cross multiply the other direction, you're going to multiply twice. 10 times x is 10x, and then 10 times 15 is 150. Well, if we go through and subtract both sides by 150 minus 150, we get 30 is equal to 10x. And then if we just simply divide both sides here by 10, 30 divided by 10 is 3. All right, 3 is equal to x. And that's the distance that I was looking for. All right, problem 7 we did in class. Okay, so let's take a look at problem number 8. So it says the following polygons are similar. Find the missing side length D. All right, so let's take a look. Here's where D is, and let's go through and play that matching game. Well, D is corresponding, is matching to which side, right? It's going to be here from H to I, which was 80 meters. So I'm going to say D over 80 is equal to, and let's play that matching game again. Whoa, go back to it. F to G, which was 48, is corresponding to from G to H, which is 60. All right, let's go through and cross multiply to solve this. There you go. D times 60 is just 60D is equal to, and when we cross multiply in this direction, 80 times 48. Again, I don't know that off the top of my head. I'm going to have to multiply those together. 80 times 48, we get 3,840. All right, all I have to do is divide both sides by 60. 60 divided by 60 cancels, and we get D is equal to 3,840 divided by 60 is equal to 64. All right, so the length of D is 64. To be exact, it's 64 meters. This one actually did have units at 64 meters. All right, problem number 9 we did together in class. Problem number 10. It says Liam is 6 feet tall. All right, so imagine there was a person here. All right, they are 6 feet tall. Whoops. And then it says to find the height of a tree, he measured his shadow. So again, he was standing here. And then he measured his shadow, which was 8 feet. And it says the measurements of the two shadows are shown. Oh, and the shadow of the tree, of course, I forgot to read that part. This is the shadow of the tree here that measures 28 feet. The measurements of the two shadows are shown. Find the height H of the tree. So we do have two triangles here that were created when we measured the shadows. So let's go through and set up a proportion. All right, let's take a look at the shadows first, though. Let's take a look at the shadows, right? Liam's shadow was 8 feet. We're going to compare that to the shadow of the tree. Those are the corresponding sides. right? It makes sense. You're comparing shadows to shadows. So that's 8 over 28, and that's going to equal, well, compare the actual heights now of Liam and the tree, right? You're comparing their actual heights. So we're going to say 6 over the height of the tree, which is h. We're going to use the letter h. Let's go through and cross multiply. 8 times h, or h times 8 is, 8h, and that's equal to 6 times 28. What is 6 times 28? I've just dropped my calculator. 6 times 28, that's going to give me 168. If I just quickly divide both sides by 8 by 8, what's 168 divided by 8? That gives me 21. H is equal to 21. The height of the tree is 21. 21 what? They were using feet as their unit of measure. There you have it.